Today we're going to talk about definitions of exponents. The exponents are one of those things you really should write down all your steps until you get really good and really understand what you're doing, so that it makes you understand it better. The base of an exponent is the number that tells what number is being multiplied. The base is only the thing that is being touched by the exponent. The exponent is the quantity representing the power to which a given number or expression is being raised. The number of times the base is being multiplied to itself. So, here, 7 to the 5th power, our base is 7 and our exponent is 5. Here, -7 is in parentheses and the 5 is touching it. So it's -7 to the 5th power. Our base is -7 and our exponent again is 5. This is negative of, because the negative's on the outside, negative of 7 to the 5th power. Or remember we talked about the opposite of 7 to the 5th power. Our base is 7 because the 5 is only touching the 7, and our exponent is 5. Here we have the quantity 3x minus 7 squared. The 2 is touching the parentheses, the exponent 2 is touching the parentheses, so our base is 3x minus 7, and our exponent is 2. This is x over y to the 4th. We have two different bases here. We have the x and we have the y to the 4th, or the y. And the y to the 4th has the exponent of 4. The x, because it doesn't have an exponent per se, it's a 1. Whenever there's no actual exponent there, the exponent is 1. This one, this last one, is opposite of, negative of, x cubed over y cubed, all to the 4th power. So we have three different exponents. We have a 3, a 5, and a 4. The exponent of 3 goes with the x, and that's the base then. The exponent of 5 goes with the y, and that's the base for that. So the base for the x cubed is x. The base for the y to the 5th is y. Now we have this exponent of 4. The 4 is touching the parentheses, so the entire thing in the parentheses is the base. So our base is x cubed y to the 5th for the exponent of 4. Notice, nowhere in there did that negative that's on the outside come into play because it's negative of the whole thing. It's the opposite of the whole thing. So if you're evaluating, and when we start evaluating, we're going to do this whole thing and then take the opposite of it. Let's evaluate the following. So this is 5 cubed, so this is saying we're going to take 5 and multiply it by itself 3 times. So 5 times 5 times 5. So that's 5 times 5 is 25, times another 5 is 125. This is 4/5 squared, so that's 4/5 times another 4/5. A quick review of multiplication: when we multiply fractions, we multiply across the numerator and multiply across the denominator. So that's 16 over 25. Zero exponents. Any non-zero number raised to the power of 0 is equal to 1. So as long as a doesn't equal 0, a to the 0 is equal to 1. So let's try these. We want the base, the exponent, and then evaluate. So this is 10 to the 0 power. So our base is 10. Our exponent is 0. So 10 to the 0, any number to the 0 power is equal to 1. The 0, so we have, is touching the parentheses, and the negative is in the parentheses. So it's negative 10 to the 0 power. So our base is negative 10, and our exponent is 0. So negative 10 to the 0 power is positive 1 also. This one, though, the 0 exponent is only touching the 10. The negative is not in with the 10. So it's opposite of 10 to the 0 power, negative 10 to the 0 power. Here our base is 10, and our exponent is 0. So when we evaluate that, we have the opposite of 10 to the 0. 10 to the 0 we just figured out was 1, so it's the opposite of 1. So it's negative 1. This one, our 0 is touching the parentheses, so it's the quantity negative 4x to the 0 power. So our base is negative 4x, and our exponent is 0. As long as x doesn't equal 0, the whole thing is to the 0 power, so that's equal to 1. This one, though, the 0 power, so our exponent is still 0. The 0 is only touching the x, so our base is only the x. So we have negative 4 times x to the 0. So we have negative 4 times x to the 0. X to the 0 is equal to 1, so it's negative 4 times 1, which is negative 4. This last one, we have 1, 2, 3, 4, 5, 6, 7, 9 to the 0 power. So our 0 is our exponent. 1, 2, 3, 4, 5, 6, 7, 9 is our base. Even though it's a huge number, it's to the 0 power, so that's equal to 1. Negative exponents, dividing is an inverse of multiplying, and negative means an inverse operation. Therefore, a negative exponent is dividing the base by itself the number of times by the given exponent. Or you can also just move the number or expression over the fraction bar and switch the exponent to positive. So this is what you want to remember. A to the negative 1 is equal to 1 over a. If you have a fraction, a over b to the negative 1 is equal to b over a, as long as we don't make any denominators 0. That doesn't go well. So let's try the base and exponent and then evaluate or simplify. So here our exponent is negative 4, and our base is x. If we want to simplify this without a negative exponent, we just want to say 1 over x to the 4th. We move it over the fraction bar and make our exponent positive. Here, our exponent is negative 3, and our base is what's touching that exponent, so the negative 3 is touching the parentheses, so our base is negative 3 also. Negative 2, sorry. Because that's what's in parentheses, negative 2 is in parentheses. So the first thing we want to do is deal with the negative exponent, so that becomes 1 over negative 2. That is still in parentheses, cubed. We flip the fraction, we move the base to the denominator and make the exponent positive, and then we can evaluate negative 2 cubed, so that's 1 over negative 2 times negative 2 times negative 2. That means that's because our base is negative 2, we're multiplying negative 2 times itself 3 times. So that's 1 over negative 8 We normally don't write negatives in the denominator, so we're going to do negative 1 over 8. 4/3 to the negative 2. Our exponent is negative 2. And our base is what's touching the exponent, so that's 4/3. Remember, our last property said if it was a over b to the negative 1, that became b over a. So we're just going to make it 3/4 squared. And that's 3/4 times 3/4. So that's 9 over 16. Here, our negative exponent. Our exponent is negative 3. And our base is what's touching the exponent. So our exponent is 3, or our base is 3p. Evaluating that, we get 1 over the quantity 3p cubed. So that's 1 over 3p times 3p times 3p, which is equal to 1 over 3 times 3 times 3 is 27, and p times p times p is p cubed. And I can switch the order because we have commutative property. Here, our negative 5 is the only exponent we have. And the base that goes with that exponent is a. So we have 1 over a to the negative 5. If the negative is in the denominator, we're going to make it go to the numerator then. So that would be a to the 5th over 1, which is just a to the 5th. The last one we have is our exponent again is negative 3. The negative 3 exponent is only touching the p. So our base is p. So we have 3 times p to the negative 3. The p to the negative 3, we're going to do the same thing like we did up here with x to the negative 4, made it 1 over x. So it's 3 times 1 over p cubed. So that's 3 over p cubed. This one we want to expand. We want to write out what it means with the definition and then simplify or evaluate. So 3 squared is equal to 3 times 3. 3 times 3 is 9. This is the opposite of 3 squared. So the opposite of 3 times 3. So that's negative 9. The base is 3 and our exponent is 2. The negative is saying the opposite of whatever we're doing. This one, our base is negative 3 and our exponent is still 2. So this is negative 3 times negative 3. Because our base is negative 3 for this one. Negative 3 times negative 3 is positive 9. Now we're doing the same things as these three, only it's a negative exponent. So this is 3 to the negative 2. That means we have 1 over 3 squared. We already found out what 3 squared was. 3 squared was 9. So this is 1 over 9. This one says negative of 3 to the negative 2. So that becomes 1 over, we can leave that negative out front, 3 squared. The negative stays out front, and 1 over 3 squared is 1 over 9. So our final answer for the negative of 3 to the negative 2 is negative 1/9. And the last one is negative 3 to the negative 2. The negative 3 is in parentheses, so that's part of our base. So that's 1 over negative 3 squared. So that's 1 over negative 3 times negative 3. So that's 1 over 9, because negative 3 times negative 3 is positive 9. We want to simplify and evaluate the following. Again, we're going to write out what all of these mean so that we can see where it's coming from. So 3D cubed. All of 3D is cubed, so our base is 3D and our exponent is 3. So this is 3D times 3D times 3D. So 3 times 3 times 3 is 27. And D times D times D is D cubed. So 3D cubed is 27D cubed. This is the opposite of 3D cubed. So just expanding it, we have negative 3, opposite of 3. D cubed is D times D times D, which there's no simplifying we can do on this one other than making it back to the original problem, negative 3D cubed. The difference between this one and this one, though, is the negative 3D is the base. Here, only the D was the base. That's why we only multiplied D 3 times. Here, the negative 3D is the base. So this is negative 3D all cubed. So that's negative 3D times negative 3D times negative 3D. Negative 3 times negative 3 times negative 3 is negative 27, and D times D times D is D cubed. Now these three have negative exponents. They're the same as these, only with negative exponents. Almost. This one is 3D to the negative 3. The negative 3 is only touching the D, so that's the only thing that moves. So this is 3 times D to the negative 3. So that's 3 times D to the negative 3 is 1 over D cubed, and then we can make it look like a regular fraction and make it 3 over D cubed. Here again, this is negative of 3D to the negative 3. Again, the base is D. That's the only thing that's touching the exponent. And the exponent is negative 3. So this is negative 3 times D to the negative 3. So that's negative 3 times 1 over D cubed. So that's negative 3 over D cubed. Or we can put the negative in front of the fraction and make it negative 3 over D cubed like that. This last one, the difference between this one and this one, the parentheses, the negative 3 exponent is touching the parentheses, so the whole thing has a negative exponent. So this is 1 over negative 3D cubed. We did negative 3D cubed over here, so this is 1 over negative 27D cubed. We like to have the negative out of the denominator, so we'll make it negative 1 over 27D cubed. That's it for today. See you tomorrow.